On today's stream, mainly continuing with the supermarket checkout pricer exercise that I've been doing for a couple of streams now. Yesterday we got to the point where we got almost all the tests passing. Did some refactoring, and now we're going to go and add some more features, and then look at a bit of hooking things up to an external service that actually provides the price for the items. So let's get to the code. So what we've got here in our project, we've got our cart service. Let me clear up the code coverage. We don't need that anymore. So let's run our tests. And so we've got one failing test. And that's the test we're going to be working on implementing. So we had done all the refactoring to get to the point where we can now implement this behavior. So what we've got with this project is as items are added to the cart, so inside of our domain, we've got a few domain objects, our cart, product, and receipt. And then we have some tests against that at different levels. And then we have our cart service, which is part of our application services layer. And so if we take a step back, and it seems my what I'm going for here is to create a small but sort of non-trivial application driven using test-driven development, but structured and organized using hexagonal architecture. So if we look at the sort of hexagonal architecture diagram of what the system is, we've got something that basically talks to the outside world. That's our product scanner. Right, so it gets input from a scanner, which sends the information however it sends it in, and then the code within our system then sends that information by calling a method on the cart service. That's part of our application services layer. It then creates a cart, creates products, and does all that work. And then the cart and the product work together to generate a receipt. We have not yet done the receipt display. And we've also, for our test purposes, we've stubbed out this product price fetcher. So that's kind of the high level view of the project where we are now. So we've got product, it's just a record. It has the UPC and its price. Receipt has the total and basically a list of string of products. This we're going to have to change because we've introduced a new basically value object for product. And cart is the calculation code for both the total price, but also taking into account discounts. So all the discount work is basically this code. And that's one of the things we're going to want to refactor. And then we can actually implement this last test, which is discounts have priorities. We may not want to give both half off the second one you buy and a 10% discount. So what we'd like is to choose one of those. So here we've decided, right, and this is a business decision, we've decided that 2 items that have 10% discount, only half off discount applies, which is actually better for the consumer because it's half off as opposed to 10% off both. But there's no sort of correct answer here. It's which one do we want? So we decided that we wanted this one, but right now, as we saw when we run the test, we see it fail because we're actually getting the 10% off both, right? So 9 plus 9 is 18, whereas what we'd like is 10 plus half off 10, which should be 15. So there's some other things that we want to look at, and that's right now what we're sending in are these strings. We're not really looking up this from any kind of database. There, amen. And so that we're going to have to figure out. So now that we have the pricing working sort of the way we want it, so basically when we add a product, it just gets added. And in fact, we don't need to return anything because this should just be a command. I don't think anybody's using the return value. So let's go fix that. And let's do a commit. Changed add method to be a command. So when I talk about commands and queries, especially in the domain layer, in the domain object layer, you generally want your methods on your classes to be of 2 types. Commands that basically request state change. So here we're adding a product, and a query which asks for information that may be calculated or maybe just returning something that is already stored. So here our query is total. And what it's doing is basically figuring out the discounted price for each of the products, and then basically does a reduce by adding them all together. So the question is this test works, right? 10% on this item, we get 9. Here, 10%, we've got 2 of them, so that means it's not being considered for the half off discount. So let's take a look at why that is. So it's basically here. So the priority in this statement is if it's the 10% off product. And one of the things that we'll have to figure out as well is how do we know which ones get which discounts, right? So there's the whole, how do we configure this thing? But for now, it's hard-coded. If it's the 10% off one, we figure that out first. So if we want only the half off your second or later purchase discount, then we kind of need to swap this. So we need to see sort of, is it eligible for half off? And then return this. Otherwise, return the other one. So let's so this code is a bit complicated, and maybe we want to refactor it a bit. So one of the things that's causing a bit of difficulty in understanding this is there is this set for eligible products. And that's used in multiple places. So that's what I wanted. I forgot the shortcut for highlight usages. So if we look at the usages of this eligible products, we see it's used here. This is when we're adding the products to the eligible list. And so we did this yesterday so that we could figure out, is this product eligible for the multi-item discount? But we can't just look to see how many of them are in the cart, right? If you add one of them to the cart, it's full price. If you add the second one, the first one is still full price. The second one is the one that gets half off. And so we basically did some coding on this yesterday and ended up with a mechanism that uses a separate set of product to see, have we seen this one before? So the first time around, when we're checking the product, we haven't seen it. Then the second time we've seen it, and all future times we've seen it before, so it's always eligible. And we only need a set, we don't need a list, because once it's in there, it's eligible. The problem is this variable is used in 3 different places. And what's even more confusing is we initialize it here, right? We basically reset it every time we calculate the total. And that makes this code a little bit complicated. And so we can't just sum over all the things and calculate the discount. We have to have this thing that tracks eligible products for us. And so with our discounted group product price, if it's eligible, then we basically return the half off price. Otherwise, we add it here to say, hey, we've now seen this. And the next time we check for discounted group price, we'll know that it's there. So this field is used in several different methods. And that means when you're trying to read this code, you have to understand what is it for and how does it get updated, and is this even the right way to do it? So I'd like to try and simplify that. Like, how do we know a product is eligible? Well, we know we need to reset it because we want to do that every time we calculate totals, right? So again, we want to not discount things until we've already seen that they're eligible. So when we discount, I kind of want to move this code. I want to kind of take these 2 methods and combine them. So this one is fine. This method I think is fine. It's basically, is this product eligible? What's confusing, I think, is these 2 methods feel like there should be a different way to split them up. And so from a refactoring standpoint, what I often do is sort of smush them together and then look to see if there's a different way to split them out that makes more sense. There's something else that is sort of in the back of my head, which is we've got a collection here and we've got a bunch of behavior associated with it. And this specific discount is not the primary concern of our cart class, right? Our cart class is doing other things. And so for me, those 3 things together, is this sort of an unconstrained type? Is there behavior associated with it? And is it in a class that's doing other things? That's primitive obsession, which is a code smell that tells me that maybe there should be a class that represents this idea of, is this product eligible? And if so, calculate its discount. And so even just with that, we're starting to see that maybe there is another class that we can pull out. There's a whole idea of pulling the discounts out altogether and pulling those out to be a strategy, which would basically be this code plus these two methods. So there's multiple strategies for discounts, right? 10% off, half off the second item, things like that. And those could be pulled out separately as well. But I'm not going to focus on the primitive obsession. I want to see if I can clean up this code first to see if there's anything obvious. So what I'm going to do is I'm going to take this and I'm going to basically inline it. So I'll get one big method. But it's not all that big. And what's nice about this is now it's a lot more obvious that this is the 10% discount thing. In fact, having to read this and know that this is the one that's 10% discount is hard, because like, I don't know what this means other than it's some specific product. And then I see the 10% discount being applied here. So let's make this easier to read by saying, pulling this out into a method, which is eligible, if I could spell, is eligible for 10% discount. Actually, let's shut the word is. It's just eligible, right? So now the priority of applying these discounts is clear. If it's eligible for 10%, we just return the 10% off. Which means it is not going to be eligible for half off. So that's because it immediately returns. If it's eligible for half off, then we calculate the half off. Otherwise, we add it to the list of eligible products for half off, and then return just the normal price. So even this variable is not specific enough. What does eligible products mean? So let's make this one more clear, which is eligible products for half off discount. And so when I'm coding, I'm constantly renaming things to make them more clear if I encounter them and it feels confusing. And so this is a heuristic I call confront confusion, where if you're confused and you can change a name to relieve that confusion, to clear it up, then do it right away, especially for fields that are private, which most fields should be, or if it's a method that's private, or even if it's a method that's public, if it doesn't affect library API kinds of things, then you should rename those as well. There's no point in keeping around confusing names. So he says, have empathy for your future self. Absolutely. And your future self might be 5 minutes from now. So these kinds of things I want to rename as soon as I can. And Siri, be quiet. All right. So let's run our test, because that was a refactoring that was not trivial, but it was inline and renamed, so it should have been straightforward. But let's run our test just to be sure. All right, so the test that we expected to be failing is still failing. But now we can change the priority. We can say, we want half off to apply first. So let's take that, move that up. Now we think that'll work. Except not yet. Because we now see that this eligible thing happens here. So is that going to work? So because it'll drop from here, but then if it doesn't get picked up, we'll still get 10% off. So this isn't going to quite work either. And so now what's interesting is I know this is going to fail. Are other tests going to fail? I don't think other tests are going to fail. But does that change how the current failing test is going to fail? I don't think so. I think it'll still be 18. Yeah. So we didn't quite fix it. So we might say, oh, well, let's just take this and move it up so that we at least account for it being eligible. So the next time around, when we ask to see if it's eligible for half off, it will be eligible for half off. I don't think this is going to work either, because I think the first time through, it's going to get the 10% discount. the second time through, it'll get half off. So I think we're going to end up with too much of a discount. We'll end up with, what, 14? Yeah, so we got 14. But notice that I predicted, right, and this is part of my predictive TDD process. I predicted how it was going to happen because that is useful information as well. That tells me I understand this method, which is non-trivial. Anytime you've got multiple ifs, you know you're getting into complicated. And so my ability to predict means that I have an understanding of how this works. So we can't just do this. So let's see. How are we going to solve this? We might have... We might have to make this eligible for 10% discount more complex. So let's move this back down. So now we should be back at 18. So one of the things that moving this around tells me is that it should actually be part of actually doing the should be part of asking if it's eligible. Let's see. So we only want to apply eligible for 10% discount if there's only one of that product. So here's where we can actually look at the entire cart. So the eligible products needed to be separate because we only want to discount the second one, not the first one. Here we want to see if there's more than one of them, then it's not eligible for the 10% discount. So we used to have a thing that counted. We took out that code, but we'll add it back. So the eligible for 10% discount is not just that this product equals this. It's also if the products, and so here we'll do a stream, and we'll filter for the products being equal. Then we'll count. And if that's greater than 1, then we return false. All right, so if there's more than one of them, it's immediately ineligible. So what's interesting about this is, did our business people realize what the implications of this rule was? Because the implication of this rule is it's only 10% off one of them, not 10% off two, because you got the 50% off the second one. Now, it's probably likely you would not apply the buy one, get one 50% off to all items, right? So we haven't quite associated items with specific discounts. But a lot of times the rules, as they're defined, as you implement them, you find that there's really an implication for what that rule really means. So if we're saying the half off takes priority, what we're saying is 10% only applies to one item. And if the rule was originally stated that way, it would have been a lot easier. It would have said, oh, okay, of course, you only get 10% off if you only have one of them. So let's see if this works. I think it will. And it does. So not thrilled with the code. And something that is also sort of tickling the back of my brain is, do we want to, as we add items, is a list really the right way to handle these? Right? Because what we've got is we've just got a list of product. You add 3 of the same product, you end up with 3 product entries. But a lot of times there are line items, right? In an order, you basically say, it's not that you have a product 3 times, you have the product with a quantity of 3. And so the quantity is associated with that. And boy, wouldn't that make some of this decision-making easier if we had a map of products to their quantity. Then we could just go through, all right, which products have 2 or more, apply the discount to those, and then apply whatever other discounts are applied to the rest of them. So that might be a refactoring direction to go. But now that our test passed, let's go ahead and do a commit. So right, because that's really what the rule is. So we have tests that basically say, well, if you got 2, the second one is half off. If you got 3, the second and the third are half off. Here we've got, if you have 1, then it is 10% off. But if you've got 2, the second one is half off. But that's quite a bit of complicated code here. And what still really bugs me is this set. Mainly it really bugs me because of it being reset each time. And that somehow seems wasteful to me, but also confusing, because you don't generally expect a field to be reset as part of a query. So one thing, and I want to note this, is that this is a query method. It is changing state, but this state is not observable, not directly. It's most certainly changing state every time you call it, although in a sense it's resetting state. But processing this code changes state. It changes the contents of that set. But that's not observable, right? Because we could have done this in a number of different ways. And if it was a local variable, right? Because we could put all of this code, we could stuff it into this method. And then this would just be a local variable, and we wouldn't say that changes state. In fact, we could actually make these sort of a bit more functional by passing in this set as a parameter instead of having it share a field. And so this is the kind of thing that you want to sort of keep in mind, is that this is a query method, and even though it looks like it's changing state, it's not changing observable state. At no time are we asking from the outside, what are the eligible products for half off? That's an implementation detail, and there's a number of different ways we could implement this. So that's great for me to notice that, because one of the things that I constantly collect are cases where it may seem like rules that I use or heuristics that I follow don't always apply. And so sometimes clarifying and showing examples of, hey, it looks like this is modifying state, doesn't that violate query, gives me a realistic example that I can use to explain it. So I'm always on the lookout for these kinds of things. All right, so we've handled the priority of these two special deals. We could probably do some additional refactoring to the code that we have. Like, for example, this piece of code, we could say, we could extract to a method. We could say, more than one of, something like that. And then this filter count. So that helps a little bit. That's sort of a tiny clarification. But I think there's a structural change that we need to make, which is, how do we associate, for example, this deal like, we should probably even be checking this first. I mean, it's not like this is terribly inefficient, but we're doing a lot of work that we may not have to do. So let's see if I can invert this. There we go. Not sure that's more readable per se. But what that does allow us to do is again, reiterate that what is the rule? It's that if this product is this specific product, and there's not more than one of, well, what's the opposite of not more than one of, right? So we now have this bang in front of it, and that makes this a little less readable. Well, not more than one of is one of. So we can unfortunately, there's no way to with a single refactoring to negate this and change this. So we'll have to rely on our tests to do that. So what we can do is we can make this first change, which we know should break stuff. So we'll run our tests expecting stuff to break. And they do, which is great. And now we can basically say this, if we change this to equal, we've now restored that behavior. So the test should pass. Now we can rename this method, because we don't want to forget about that, otherwise the method name is lying. And now we've simplified this method. We've put this first because there's no point in looking for the discount unless it's one of these items. And we've basically inverted one of these manually. But note that we did it one step at a time. We changed a little piece of code, expecting it to fail. If nothing failed, that would have been concerning, because it would have meant that we don't have as much test coverage as we thought we did. So let's go do a commit. Small refactoring for eligible for 10% discount. So let's reorganize the code a little bit. Let's take all these private methods and put them here. I'm going to take these public methods and put them here. So code organization is really interesting. I am not as strict as I think some people are. Some people like to put all private methods at the bottom, and then all your public methods at the top. I tend to do that, but I also don't want those private methods to be too distant from where they are in the code from the sort of method they're being used from. So it worked out that all of these methods are totally related to this total method. So that way it's the last public method. But what's interesting is when I think about sort of how would I organize just the public methods of this, and I know this is getting into really OCD like, almost OCD like behavior. I tend to think of the sort of priority or quality or importance of those methods. Total to me feels more important than something like receipt. Receipt feels more terminal, so I feel like it would need to go after total. But anyway, that's kind of the way I think about it. I don't worry too much about that because I generally don't navigate code by trying to find it in scan files. I do a lot of jumping right to things. So let's just do a commit. Do that. All right. Let's look at our project. Okay. So we could continue adding discounts, but I think we're at the point where I want to take a step out and say, okay, well, how do we know specifically for this product, right? This constant literal, which I guess is redundant because all literals are constants. This literal is problematic, right? Because this is a specific UPC, and how would we configure this? And as I mentioned yesterday, the tests that use this, it's not obvious why this one is eligible for a 10% discount. So it seems like we want some way of querying, of something being responsible for saying what discounts are available for a product. We could immediately jump to something more complicated, but I'm going to do this just, sort of small steps. So there's actually two parts to this rule, right? There is the product itself eligible for a 10% discount. And then we further apply the rule, and there's only one of them in your cart. Those I feel like are two separate things. Because that's what it feels like. Doesn't mean I'm correct, and certainly we could say, well, this one we want a 10% discount only if there's one. This one we want a 10% discount if we don't care. It always gets 10%. And then you'll get into complicated scenarios of, well, okay, if this other product is 10% off, and there are two of them, which takes priority, the 10% off or the half off? And that's where you'd have to really split out the application of the discounts to the specific items. So I'm reminded of something that somebody posted on Twitter yesterday, which was about we coders tend to be attracted to complexity, and if we don't find it, we sometimes create it. So I don't know, that just came to mind because I'm thinking about all the complexities. And I think, though, that's an important thing to think about, because that, I think, is what makes our code more complex than it needs to be. And this is what I like about test-driven development, is it really guides us to writing the simplest thing to get the thing to work, to counteract our tendency to write more complex code than perhaps is needed. So let's just say we want to be able to now apply this rule of 10% off to more than just the 0987 product. So what would we do? That's when it would become clear there needs to be something that can basically tell us yes or no for this specific expression, right? Can we even consider it as being 10% off? I hope my video is not blank, because I would have assumed somebody would have told me. Might want to refresh your browser if you're getting a blank screen. So in order to basically externalize this, we need to... Oh, you have a number of streams. Yeah, if you have a bunch of streams running, your browser might not be able to keep up. But welcome. So I just did a test. I'm seeing my stream on Twitch, so I'm afraid to say it's on your end. So how do we externalize this? So we can't, remember, we're in a class that's in our domain, right? So going back to our diagram, right? We're looking at code that's in here, right? This is inside of our domain, right? This is our core domain. So our core domain must not have references to anything outside of the domain. So we can't inject something like we can't have this have a reference in its constructor to some service that would look this up. But we're getting a product handed in. So why can't that information be in the product? That makes sense. In fact, that would be a good use for product, right? Because the product is being handed in because that's what's being, that was what was originally added to the product in the first place. So if we think about what is product, right now, it's literally just a bag of data. It has a UPC and its price. So in addition to its price, maybe we could have its discount or some kind of discount rule. And this gets into, how do we discount? Do we discount per item? Sometimes, often. Sometimes we discount according to category. Like, hey, all produce today is 10% off. But right now we don't have a feature for that. There's nothing telling us that we need to do that, so we'll leave that alone. So it seems like product then should have additional information about what kind of discount might apply. Right? Is this eligible for buy one and get one half off? Because we actually don't want it for all items. Maybe we only want it for our toothbrushes. And so product would need to have the information, right, of something like of some discount rule. not actually writing this code, I'm just sort of sketching it. So, because I'm not allowed to write code unless I have a test that fails or unless I'm doing refactoring. So this is kind of what I imagine it would look like. So if we're saying that that's what we want, then we can do this as a refactoring, right? Because our behavior is what we want. We're just uncomfortable with some of the code in here. And by the way, if you're watching along, as I push code, you can track it on the GitHub repository. Just make sure you look at the hexagonal architecture branch, because that's where we are. There's actually two branches. There's one called Stream, which was my original trial. So let's go to that branch. There we go. So that's the specific branch. So that means that product has to have, along with it, what discounts it's eligible for. Well, let's drive this with a test. Not drive it with a test. Drive it by changing a test. Actually, I think since this is a refactoring, we could modify product and then have all the code, basically modify this records, in a sense, constructor, which would modify all the code and put in something that would be a default. So this is our special deal test. Let's actually take a look at just our regular cart test. So here, the no discounts apply. So what do we want in terms of the rule? We could start just with an enum that specifies what rule applies. And just do that for the 10% off. So let's start there and see what happens. So let's go to our 10% rule, which is this one. Let's pull the product out into a separate variable as part of our setup. And what we'll do is we'll add, now here's where we want to have a backwards compatible constructor. Or we could just have a default for that. Let's see. So let's create something called discount rule. And we're going to say this is 10% off. So we'll create an enum. This is in our domain. And then we'll create an enum constant, 10% off. So that's there. Now I want to create a backwards compatible constructor, or do... Let's see what happens if we create a constructor. So this is our UPC. This is our product price. This is our discount rule. And I have no idea what it just did here. Oh, IntelliJ. All right, let's back up. So what happened was when I created the enum, it created it in the test directory. And it didn't ask me where to put it, right? Now I'm like, hold on, let's undo that. Let's undo creation of that. Let's go back here. So when I created this class, this as an enum, so it defaulted to tests. I should have selected that here. Okay, let's redo this the correct way. And now I'll create the enum constant. That's fine. Now I'll create the constructor. And now it's not, now that's fine. Okay, great. So let's bind these. Why did you do that? That's not quite what I wanted. UPC is Universal Product Code, is basically the barcode that you find on all products that you purchase anywhere. I don't know if it stands for universal or uniform, but it's basically the barcode you see on your products, and that's how you know when you scan them how much they are. No. That's a really strange thing it did. I wonder if it's because if I do this, oh, I see what it was doing. Okay. So this can't be final unless I actually assign it. So let's say it was null. No, wait, this is an instance field. I can't have this in a record. What was IntelliJ thinking? So I think we need another constructor. I don't know, actually, so in records, can you have a constructor? Because really what I want, okay, really what I want is this. So let's delegate well, that's what why did, so IntelliJ should have basically done this, except I've already got the parameters, so it should have done that already. So whatever. All right. So what I really want is a constructor. This is annoying to do with records. Product price and then null. That's what I want. So basically, if you don't specify a discount rule, then it's null. Yeah, it's Luca's. Everything is final. You just can't specify your own. So this is what I want to. So by default, UPC product price discount rule is required. But if you only specify these two, then it fills in discount rule with null, which I don't like. But let's make sure everything compiles, because we're in refactor mode. So let's make sure we haven't broken anything. Okay, great. But I don't like null. Let's fill this in with a discount rule of none. So at least we have something that's not null. Okay. So now this test abides by the good test heuristics, right? It's arranged into the three parts that we want from a test, given when then, right? So given a cart and given a product that has this UPC, has this price, and there's this discount rule, when we add the cart to the product, then when we ask for the total, we expect it to be 10% off of 10, which is 9. The product, while this product is immutable, if the discount changes, we just throw the old one away and create a new one. So right now, products are not persisted. Where do they come from? Right now we make them up, but where do we want them to come from? Is that information will be passed into cart when we do an add, but at that point we would have looked up what the discount rule was at that point. So once we've added it to the cart, by the way, this is an interesting. I ran into this some years ago. So here, the local Safeway supermarkets, they change over their discounts basically Wednesday. Turned out I was shopping very late on Tuesday. You can probably guess what happens next. It turned out to be after midnight. And so the discounts were not what I expected, because it had switched over to the Wednesday discounts. So if the product was it's basically the discount at the time the product was added to the cart. But anyway, so this is not persisted, so I don't have to worry about it being final. And once it's in memory, the discount doesn't change, so that's fine as well. And so this is a value object. Right? It's immutable, and it has attributes, and it describes stuff. And so, yeah, that's all good. But as I was saying with the test, we now see this rule is explicit and tells us, and this is information we didn't have before, why did we expect this to be 9? If we wanted to make this even more clear, we could pull this out into a variable and call this 9. But I think this is fine. Although I don't need value of 9, I can just say 9. I think I had that because I forgot that it was equal by comparing terms. Okay, so that's even better. Great. So now our UPC, our product has a discount rule. By default, it's none. Here it's 10% off, except of course, in our cart, we're ignoring that. But that's fine. This was a refactoring, so we can say instead of product UPC equals this, we can say product discount rule equals discount rule 10% off. There is no big decimal .9. They did not expose that as a constant. 0, 1, and 10 are exposed. 9 is not. I actually looked. They actually keep an array of them, because when you do a value of and it already has it, then it pulls it out of the array, but they didn't expose it as a constant. At least not in my current version of Java. So this should be equivalent to what I had before. To be clear, I think I need to refactor my tests a bit. Let's convert this into a constant. Product with 10% off discount. Because while this is equivalent code, this does actually change behavior. But we've got tests to make sure that things that shouldn't have been discounted aren't. And this one, which does have a 10% off discount, should be off. So now I can replace these with a constant. And so this should be equivalent. If it's not, then I've done something wrong, but it's equivalent. Yeah, I wasn't going to even address that. All right. And so I can prove to myself that this code is doing something, right? So I like to do these manual mutations. So I'm going to say none, and this should break a whole bunch of things, because everything that was not supposed to be discount will be, and the stuff that is won't be. So I expect to break like 5 or 6 tests, if not more. 7 tests. So the one that we were looking at is 10% off, didn't do 10% off. The ones that did do, that should not have had 10% off, did have 10% off. So what's nice is it failed in the way that I expected. And so I often do these manual mutations, either part of trying to get the test to fail in the first place, or really checking, is this being paid attention to? Is this code actually called where I want? It's Luca. This is why I'm using big decimal, so I don't have to figure out floating point error. Whenever you're doing monetary amounts or anything that deals with decimals, and basically you're not doing things where you don't care about like basically money stuff, you want to use big decimal, or money, which uses big decimal underneath. But the 9 isn't what? This is 10% off 10 is 9. Although you did point out that it did make me realize that product priced at 10 and 10% off discount. There we go. The 9 is totally decimal. Just because I don't have a decimal point doesn't mean it's not decimal. I'm not quite sure what you're asking. It's Luku. So I can say 9. I can also say 9.0. I can say 9.00. It doesn't care because when it does this equal by comparing to, it ignores precision. Right? 9 and 9.00, as far as I'm concerned, are equivalent. And the assert.j library handles that for me, because I wrote it. All right, so we've replaced our checking to see if the product is a specific product, has a specific product code, with now, does it have a specific rule? So that was refactoring. Let's go commit. Moved specific check of UPC to looking at products discount rule. One of these days I have to think about whether I want to extend assert.j's big decimal support to be able to pass in ints or longs here. Probably longs. Because if you don't have a decimal, then expressing it as a string is a little bit odd. But what's nice about doing it this way is I can say, you know, if it was 9.25, I don't have to say big decimal value of this thing. So, all right. So we applied our rule. Now that we have a rule in place, let's go. Do we want now to? Let's actually. Do I want to write a test? I don't think I need to write a test. except I don't want to leave it as this. Did I just commit that? Darn it. I'm going to have to amend that commit. I said accept mine. What are you talking about? Okay, IntelliJ, you're confused. All right. Okay, that's fine. And let's push. I think I should have done a rebase in that case, not a merge, but whatever. Okay. So all our tests pass. We're now applying the 10% off rule. This is interesting because we're saying that it has to have 10% off. But isn't that part of the rule? Who knows? We'll leave it for now. So it's Luca, you're confused because it's not a big decimal. Right. This string is not a big decimal, but it is converted to a big decimal for us by the is equal, by comparing to assert J library. So internally it does, if you pass it a string, it does, because big decimal, right? Big decimal, you can actually create a big decimal with basically a string, and it will parse it. And so that's what it's doing underneath. So this is the same thing. But I decided I didn't like that because that's more noise than I need, and it knows it's comparing it to a big decimal because total is returning a big decimal. So it knows. So this equal by comparing to is the abstract big decimal assert, and so it knows how to handle that. Yeah. All right. So all right, my tests are still running. Okay, great. I'm still passing. Great. So let's see. So now, if we look at our cart service, when we see add product, there's an implicit no discount rule. So one of the things we want to do is right now, when we add a product, how do we know when it's discounted? So here's where we start integrating with some other service. Yeah, and Sugi's correct. I mean, you look up. Yeah, so basically, big decimal has a way to convert from string to its internal big decimal, and basically just parses it. And in fact, you can have it parse all sorts of different things. Yeah. So here, when we're adding the product, right? So the cart service is in the application layer, right? So it's here. And so we can access through the port the product price fetcher. And that gets our price. We can have then another service with another port that fetches discounts. So let's do that. Let's come up with a port. Let's grab you. We're going to put you up here. Now you know why it takes me so long to create these diagrams. On one of my streams, probably next week, I'm going to work on my diagramming software that I've been wanting to do for a while. So now we've got a port, and what goes in that port will be an adapter. Which will be the discount fetcher. And doing the rotations of these things is much easier with math than doing it by the eye. Service is part of the application services layer. So in hexagonal architecture, there's a layer that's part of the hexagon that's in between the outside world and our domain is application layer, and that's where the application services live. So you can consider it an API for your adapters. It's not an external API, but it is an API. And the reason why I want to be clear about it's not an external API is most people today think of, when they hear API, they assume HTTP web API. But API is any application programming interface. It's anything standard that you can plug into. So the service is the API for our application, but it's not meant to be connected to directly by a web request. If you're going to do that, you have to go through an inbound adapter. So what we're doing is we're actually writing tests. Oops. So what we're doing is we're actually writing tests against this layer directly. Right now, we actually don't have a product scanner adapter. So right now, this thing doesn't talk to the outside world. So we're testing it at this. And what we're going to do is we're going to replace this thing with a dummy. So generally, our outbound adapters, we replace, especially the ones that are fetchers, we generally replace fetchers with stubs. That's kind of my heuristic. And this goes with some of the naming stuff that I'm trying to pull together, which reminds me I have to go back to that article today. So our discount, so we already have a stub for our product price fetcher, even though we don't have a concrete implementation, because honestly, I don't know who to talk to yet to get that information. We have a representation of that port here. What we're going to want to do is introduce another port for our discount fetcher. So I don't think a lot about design patterns. The design patterns that might come into play is strategy, but the design patterns that I'm using really are more associated with the hexagonal architecture, right? So having separate layers, having individual implementations, having ports as interfaces to invert dependencies. I don't think a lot about design patterns because I find that there's a tendency to overuse design patterns. You want to use what's appropriate. I don't even know that we have a factory anywhere here. So there's not much in the way of design patterns yet. As I mentioned, we probably will when we implement cart. When we're figuring out the discount, we might have a strategy, right? So for this rule, here's how you apply the discount. That would likely be the strategy pattern. I don't think I have any factories though. I mean, unless you consider constructors factories, because technically they are ways to create objects, but they're not separate from the constructor. All right. So we figured out that what we're going to want to do is cart service. So now we were doing a bunch of tests at our domain level, right? We were basically doing a bunch of tests directly against this layer. And now what we want to do is, and so that's why we were hard coding the discount for a product. But ultimately, the domain has no idea what the discount should be. So that's the job of this discount fetcher. So there's some service, there's some external service, which would also likely, which would hopefully be hexagonally driven. And I'm actually going to write some small services to serve the role as external implementations of these. The product price fetcher will be trivial. The discount fetcher will be a separate bounded context that has to do with applying discounts. And it's a separate service. Doesn't have to be a separate service. So I might actually create a separate module for that. But anyway, right now, all we know is there's some discount fetcher that is external to our system, and we need to get that information. The domain cannot get that information. That's by the time the domain has a product, that information is already embedded. So the cart service needs to coordinate that, find out the price, find out the discount, if any. And in a sense, what it's doing is it's figuring out how to manufacture that product because it's transient. And that actually presents some interesting, right? Speaking of the timing issue I mentioned before about Tuesday midnight, Tuesday 11:59, Wednesday midnight, the price switching. We would not want to, when we persist our cart, we actually don't want to persist the full product with its price and discount because that could have changed. Prices go up and down, especially these days, they go up, and the discounts change. So this also leads us to, like, does the cart really need that information? Or should it be, should we hand in some representations of that in memory? There are all sorts of questions around that we'll get into at some point. All right. So we're coordinating the fetching of the price, but now we're saying we want this product. Let's actually pull this out into a variable. So we've retrieved the product price from this external service, and now we want to retrieve the discount. So that means we're going to need a test to drive this behavior. So let's find out where our tests are for this. Whoops. That's not what I wanted. So we've got add product via cart service. Awesome. That should go over here. And our test is going to be add product having add product with 10% off discount rule. And then with, sorry, I'm just noticing that so IntelliJ you can turn on where moving forward a word goes through the camel case. It seems to jump over the 10, which to me that's a bug. I think that's a separate word, but anyway. So add product where discount service has 10% discount rule. rule is applied. That's a bit of a long method name. I don't need to say add product, so because that's part of the test. Okay, that's good enough. And so 1995. I agree. Naming tests is one of the hardest things, but it's one of the nice things is once you've figured it out, the rest is mechanical. But yeah, in general, naming things is hard. But I think tests to me is a bit harder because there's no natural abstraction. Like I can, think of, great names for classes and even for methods because they're abstractions of things. Test names aren't abstractions. They're just nouns. And that's what makes it, I think, a different kind of difficulty. All right. So let's create our product pricer stub. Whoops. And our cart service. We want 10%. Let's use 5 here. No, let's use 8 just to be different. That's our cart service. We're going to need our something else, but we'll do this. So cart service. When we add the product with the toothpaste UPC, then we expect that cart service total I don't have a live template for that. Hold on. I want to create a live template for this. So if you're not familiar with postfix, auto-completion in IntelliJ, you're about to get learned. So let's go here, file and code templates. Oh, look, I already have it open. Live templates. This is a postfix, so I don't need to surround with. So I'll add, basically duplicate this one. This is going to be sort by comparing to. So sort by comparing to. Assert that, and this is so this is assert equal by comparing to. Yeah, I agree. It's not always obvious about domain terms and behavior and things like that, but I'm often extracting code and creating abstractions. And so the domain is, it's already a small piece of it as opposed to something a bit larger like a test. So, all right, so one is equal by comparing to. Actually, I want this to be a surround. Or is it just a postfix? I forget which one I want here. So let's do this one. So we want I want the other one. Actually, that should have worked. Oh, there it is. Oops. So there's that one. So it is a surround with. Because this is the autocomplete. which is this one. Yeah, that's not the one I want. I want this around with, right? Yeah, the problem with just an is autocompletion isn't enough because they both start with is equal. I'm not in postfix completion, you're right. That's why. And what's interesting is they really need to group these things together. The whole what's really frustrating is the whole postfix editing experience in IntelliJ feels like it's been incomplete for 10 years. Like, this thing has not changed. I have at least 2 open issues against this dialogue to make this easier. For example, you can't change this description from this UI. You can actually change it in the XML, which gets stored, but you can't change it here. And it's really annoying. All right. Yeah, so I have the raw assert that. I have this one, but I want to duplicate this one. So let's go duplicate. Why won't it let me duplicate? I don't know why it won't let me duplicate. We want anything that's really non-void. That's fine. And apply to topmost expression. And so here, this is the expression we want. And then this is end. Use static import if possible. Yes. Why didn't it let me duplicate though? Can you not duplicate your own? Yeah, I don't think the duplicate button works. And clearly alphabetizing doesn't work either. I'm also loving the fact that it changes the end location to this XML spot thing. I don't know. All right, let's try this again. The whole point of this was to do that. Okay. Yes, please vote for the issues. I'll post them later. Please vote for issues for improving custom postfix creation. Hey there, is it Loden Rogue or is that an I? I can't tell the difference with this font is that's an I or an L. But what am I working on? I'm working on what it says at the bottom of the screen. I'm working on this checkout pricer. You can always do bang project and that'll tell you what I'm working on. And so what I'm working on is what's often given as an exercise to people who are learning, and since we're all learning and therefore we should all do it. And so I'm basically taking this exercise of how would you calculate the total of items in a cart given various discounts that could apply. So items have prices and you apply discounts. And so I'm doing it test driven, but I'm also organizing the code according to hexagonal architecture. So right now what I'm doing is I'm adding the ability to specify the discount rule for a specific product. So right now it fetches, when it adds the product to the cart, we get a UPC, which is the product code. We go look up the price, and now we're going to go look up, as a new service, we're going to go look up the discount for it. All right, so we expect that if the discount was applied, then this should be 7.2, if I know my math correctly. And by the way, for those of you who are not already a part of my Discord, always looking for new people to join our community and discuss things and ask questions, things like that. Oh, great. All right. This should most certainly fail, because right now, by default, there's no discount rule. At least not for a single item. So we expect this to fail. It will fail because we'll get no discounts. It'll be 8 instead of 7.2. 0. That was not what I expected. That's troubling. Why is it 0? Ah, okay. Perfect example of why predicting failure precisely is so important. Who can tell me what's wrong? It's very subtle. And I'm writing this down because I want to, because I'm always looking for examples of where these kinds of things happen. So this test failed. The expectation is that this test should have failed because of, I said the price was 8, right? My product price fetcher, when you ask it for a price, it should return 8. Technically, it's not a stub. And that's possibly confusing. But why did this test result in 0 instead of 8? Nope. It was integer math that does the stub return 8? I'd program the stub to return 8. If we look at the implementation of this, it's basically a map. But now, given your knowledge of what the stub does, why is this test failing in the wrong way? They both start with tooth. So when I did the autocomplete, it picked toothbrush. And so what happens is the stub, it should really, it's a programmable stub. It's a little bit too flexible, perhaps. So it returns 0 if it's not in the stub. Yeah, I do need, yeah. But this is so important of, if I didn't predict precisely and stop because it didn't fail in precisely the way I predicted, I would have assumed that everything is fine and continued to work on the code. But now, and then would have wondered why something didn't work. Now I've caught myself early, and that's one of the main reasons I do the precise prediction, is because if it fails for an unexpected way, it means something's wrong. Could be you misunderstand the code, or it could be that there's a problem with the test. No, it returns 0, which is, now that we understand, now we can predict, oh, this should return 0 because the product we added is not the product that's in the stub is not the product we added. Right, so now that's our hypothesis, and it now matches. So now if we change this to toothpaste, now we should get 8. And we do. Yeah, so that's a question for what is the proper behavior for asking the pricing system for a product it doesn't know about? Maybe it should throw an exception. And I don't know why override is on. Hey, Dean. Sorry, I missed your chat message earlier. You looked up the difference in code and test coverage. The difference is the code coverage is lines of code covered. But covered by what? Right? That's the thing. When are you measuring? This is a discussion we had yesterday. When are you measuring lines of code covered? Covered by what? When? When you're running the application normally? Right? When you're trying it out manually? I mean, so then that's test coverage, right? We're always checking lines of code covered. So test coverage is features covered by tests. I don't know that that's a common enough term. So is it features versus lines of code? I don't find that to be a common understanding of the differences. I think they're equivalent, but I call it test coverage because it's initiated by tests, and it's focused on code executed by tests. I don't even think coverage is a great term either, because you could execute a lot of code that is not actually asserted by any assertions. So I think I'm going to make the stub throw an exception. This may break some tests, but I'm going to say throw I'm going to create a domain exception because I think actually this should be part of the contract, because I could call out to an external service and it may say, hey, I have no idea what price this is. I don't give products away for free just because I can't find them. Let's create a class. This is... Is this port or application? It's specific to this port. I'm going to leave it in the port, but it is code. So we'll do that. I'm going to bail out of this. Does not extend throwable. I want it to extend runtime. And then I want to override these two. Actually, it should always be this. Product not found for UPC. Let's change this to UPC. All right, great. Yeah, I mean, if I'm TDDing, I generally don't care almost at all about code coverage, except when I'm doing certain refactorings. And this is how we got into it yesterday, which I thought, and Swiggy mentioned this, and I think it's a really good technique, is if you refactor by creating a new class, you've now made public likely methods that were not public before. And so how do you know that now all this code in this new class is tested properly? Because you test drove it indirectly, and now you have direct access to its API. And how do you know that now it's well covered? And so we saw yesterday, actually, there was some stuff missing. So we used the test code coverage to illuminate that for us. Yeah. But yeah, that's what I love about TDDs. By definition, if you were taking small steps. So I've seen it, and I've done this myself, where if you take too large of a step of implementing behavior when a test was failing, you may not have covered that new behavior sufficiently in terms of checking all of its decision points. All right, let's run our tests. Actually, and let's make sure that it throws the exception here and nowhere else. Okay, so only one failed for the right reason. And by the way, this is something that I was recently skimming through Growing Object-Oriented Software Guided by Tests, or the Goose book. And this is something that they talk about improving the diagnostics for failing tests. And so that's what we did with load and rogue suggestion. 5761, is that a year? I don't know what the current year is. All right, So now it should fail because it should be 8 and not 7.2 because there is no discount applied. Great. Now it fails as appropriate. Let's actually... No, I'll do a commit. Well, let's do a commit. Oh, okay, because it could have been a year. Stub throws exception when product not found. This should be part of the ports of the price fetcher ports contract. All right. Let's commit that. It's funny how numbers stick with us. I still remember my, like, if you'd asked me phone numbers from 40 years ago, I would not remember them, but I remember my CompuServe ID. Yeah. Because basically it was my username, so I remember it. All right. Test is failing as expected. Now we can finally implement some behavior. Let's close our stub. So what we want is we want something that gives us a discount rule. So discount rule. There, we've implemented it. Yeah, I wasn't big on ICQ, so I know I had one, I don't remember it. All right, so I tried the simplest thing that I thought might work, which was, well, let me just add 10% off every time a product is added. So the current test passed, so I know it works in this case, but then I've broken 4 other tests. So that's not going to work. And that was not the name that I wanted. So now I need a way to fetch it. So let's go and how do I want to do this? What I want is I want a method that takes a UPC and returns a discount rule. Is that gonna... I might have some dependency issues, but I'll figure that out. Oh, Sid Mengi, thank you for subscribing with Prime Gaming. I really appreciate that. Thanks. And welcome. Well, the UPC is just a string. So sort of the architecture of this system is there's a product scanner, and what it sends in is the UPC. Right. Actually, we did a little research yesterday on how self-checkout machines work, and that's what they do, right? They scan, they get more information than the price. They get the weight, they get categories, they get a whole bunch of information, but all that's really scanned is the UPC. There's some other codes that it can recognize as well, but it uses that. So that means we have to go out and fetch the discount. We're currently fetching the price, so that's cool. But we need to now fetch the discount. So, yep. So let's go replace this constant because this doesn't work. We're going to extract this to a method and then move it. Discount rule 4. We should pass in the UPC. And then what we can do is we can say what was the one we had, the discount rule? Let's go our special deals. So our 10% discounted UPC was this. So let's take that. Put that here. And now let's replace both of these with a 10% discounted UPC. Okay. So I've mainly just extracted this to a method. I'm not looking at the UPC, but now I could. So I should still have the four tests failing. And so now if UPC equals 0987, then that, otherwise we return none. And this is a direct return. So this should now work. And it does. All right. So so we've hard coded it in the cart service. That's not good enough. We know we don't want that. I mean, if this was the only product that ever got 10% off, then that would be great. But we know we don't want that. So now what we can do is we can extract this method to another class and extract from that an interface. So note that I could have defined the port up front, right? The interface, discount rule 4 that takes a UPC, written a stub for it, plug that in. But my tendency is to write little bits of code and then refactor them to where they need to go. So in some sense, it's a bit harder because on the fly, I'm doing design. But I know what the design looks like because I do have this in mind. And so I do know I need an external fetcher, but instead of, in a sense, doing what some people call top down or outside in, right? I think it's really top down. Like, here are all the classes and all the interfaces, and then I'll write the details. I'm really basically taking code that works and pushing it around. So let's go extract delegate. Yeah, extract delegate. Sorry, I'm already thinking ahead because IntelliJ is notorious for doing this refactoring not quite right. Let's see what it does. So we want this discount rule. What's nice is that we can look at this method and we can see the only dependencies it has is on the parameter, which is great, or on discount rule itself, which already is setting off little alarms about dependency direction, but in hexagonal architecture, because discount rule is here. But I guess discount fetcher can have that. That actually dependency direction is fine. That's stick. Maven forever. Maven forever. All right. So the name for this new class is going to be our discount. What do I call it? Discount fetcher. Discount fetcher, but a specific one. This is our stub discount fetcher, which ironically is going to go into the test directory. I probably shouldn't do that just yet. Let's leave it in the same source root. So this is the method we're pulling out, and let's refactor. See, what did you do, IntelliJ? So notice that it refactored this code, but it then still left this method here. Like, IntelliJ has a bad habit of not cleaning up after itself. It happens in this refactoring, and it happens in the move instance method refactoring. Because up here, it's now doing stub discount fetcher right there. Where that gets instantiated, that's up here. And what's nice about this is we'll be able to push it out through the constructor. One of my favorite refactoring. All right, so let's get rid of this. This should not have changed anything from a behavior standpoint, so our test should still pass, and they do. So let's do a commit. Extracted discount rule lookup to stub discount fetcher, not fetcher. There we go. All right. Just want to change something. That's what I want. Okay. So those of you who want to be following along at home, just a reminder, you can always do bang project. And you can always chat about this stuff on Discord. By the way, I publish a newsletter around once a week where I have articles either about test-driven development or a lot of upcoming ones about hexagonal architecture. And I do have my hexagonal architecture course coming up, launching it next week. So I'm getting ready for that. It is not complete yet. You'll be receiving the first few videos and then videos over the next few months. But it's a course I've delivered not quite 40 times, but close enough. So you can get information by signing up for my newsletter there. All right. Now back to our show. So now that this works and I've extracted the stub discount fetcher, let's go and we want an actual interface. So, right, so this is an actual port interface. We want this to be a port interface. We don't need that constructor at this point, but we want to extract an interface. So let's do that. So extract interface. We want to rename this class to be stub discount fetcher. No, we want to keep this. We want to extract the interface. I'm usually doing the other one, but this one we want discount fetcher. That's the package for the interface. Leaving same source root. That's fine. That's our method. No, not that. We want port. And that, I actually do want rename original, but this, all right, I'll just do it this way. Oh, now it can analyze usages and replace them with discount fetcher. Yes, please do. Could this dialog be any smaller? So yes, we want that field to be discount fetcher. Do it. Say what now? There's some bug there. Wonderful. What did you do? We've got our interface. It's in port. So what the heck happened here? Oh, because this is in a different package. Why did you not import this? Well, let's move this to the correct package because it really should be in port. I'm not going to move it also to the test because I want to do one thing at a time. Okay, that now works. And now I don't need this. Okay, but now I want to move this to the test route because this is for tests only. Right, because it did not replace... Ugh. Do I back up and do this again? Now, I'll let the compiler tell me where things are wrong. Yeah. So it shouldn't be this. It should be discount fetcher. Oh, that's interesting. I should have pushed it out first. Yeah. I should have pushed it out first. All right, let's back up. Should I just back up to... Yeah, let's just back up. All right. And this is why we do commits. No, I knew it was complaining about it. I thought it was complaining about just the declaration part, which would have been valid, but it was also complaining about this. Okay, so let's make sure all our tests pass. Complaining about. All right, let's do this again. So let's go to our stub discount fetcher. Delete this. Do I want to push this out yet? Yeah, so let's push this out. So we'll move the initializer to the constructor. Do I want to have an alternate constructor? No, I'll push it out to everybody. So now that I have it here, now I'll go ahead and introduce parameter. Thank you for that awful name, IntelliJ. Discount fetcher. Hello, Mark Zuckerberg. Now, let's run all our tests. This will get renamed later. I'll put this dot in front of it just for future protection. So let's do a commit where we pushed out my introduce parameter. Parameter. Okay. Now I can go in my stub discount thing. And now I can extract interface. Actually, let's rename it. Wait. Let's do that. That's probably what I should have done before. Now let's extract interface. Rename the original to stub. Extract the interface. Oh, this is in the wrong package. Hold on. Let's put this in the right package. Really? Is this because that's package access? Oh, that's probably why it did that. So this is fine. This can be public. Yeah, I think when I extracted delegate, I should have put it directly in port. That's what I missed. All right, so now I can introduce. So let's rename the. Oops. Let's rename that. Oh, you're kidding me. So I'm hitting Option E, which should be selecting this. But it appears to be broken. All right, we're renaming stub discount fetcher. Leaving same source root. This is the method, refactor. Okay, this looks good. This looks good. And this is exactly what we want. And we can check that we're still abiding by hexagonal architecture, because the imports that we should see here are either in either a port or domain. And that's what we're seeing, so that's all good. Let's run our test. It shouldn't have changed anything, because in our tests, we are instantiating the stub discount fetcher. So that all works. So extracted port interface for discount fetcher. Java 1994, caffeinate. Oh yeah, you know, I still have coffee. Not hot anymore. That reminds me, I need to go buy more coffee. Go buy more coffee. Okay. All right. We extracted our port. So again, notice that the way I did this was I didn't create the port first and then create a stub implementation and then inject it into cart service. I actually started with working code in cart service, pulled it out into a stub one, extracted the interface, and now I need to move the stub into the test package or test directory. Same package. That should still work. It does. Okay. All right. Now we have, yes. So now if we look at this test is problematic because it is not obvious why, let me pull this out into a variable. It is not obvious why we expect 7.2. There's nothing looking at this test. We could look at 10% discounted UPC, but that's a bit misleading because it's just a UPC code, which is redundant. It's like saying ATM machine. That's just the number. That even though we call it that, this constant there's no information in this constant that tells us anything about that. And in fact, I'm going to inline it because that's actually a little confusing. Let's inline all and remove the method. Who else is referencing it? Just there. Okay. So we'll inline it and remove the field. All right. Now it's crystal clear that if we look at this test, there's no rational, there's nothing in this test that tells us why we would expect 7.2. And what I want for my tests is it should be clear what, as part of the given or the when, makes this then obvious. So there's hidden information, right? This is actually hidden. Specifically, this is hidden. So what we need to do is unhide that information. So let's do that. We've already got UPC. So let's do this. So let's create a field for this. Discounted UPC. And we'll initialize that in the constructor. We'll take this rule. We'll refactor this into a field. And also initialize that in the constructor. Pure refactorings, pure extracts. Everything still passes. But now I can push this out as a parameter. Let's make IntelliJ less annoying. Still annoying? Something in IntelliJ changed recently where it's now just really trying to make them different by adding one. And I don't know how to fix that because that's really annoying. Because there's no reason why I can't call it this, because I just disambiguated it with a this dot. Anyway, introduce parameter and introduce parameter. So I've pushed out what was hidden here, pushed it into the fields, and then use that to then push it out into and introduce parameters. This is a maneuver that I do frequently. We saw it a bit with the fetcher, and this is the same thing. I don't have a great name. So I have a name, a nice name for cohere method, which is the series of automated refactorings to move behavior where it belongs. I don't have a good name for this refactoring, this composite refactoring. But I generally call it push out, but it's not specific enough. But anyway, what we end up with is now this information here. It's very clear that this 10% off is associated with this. And then people reading this test can associate these three things together. And now all the information you need to understand why we got here is up here. And that's our goal. So now that we've done that, no, I did not want to do that. So everything should still pass. So those were just refactoring. Expose hidden collaborator. In this case, it's not quite a collaborator, but I do like expose hidden. I think expose hidden information. Maybe we could see that as a collaborator. I tend to think of collaborator as more sophisticated, but maybe that's collaborator. That's actually not a bad name. By that I mean it's better than anything I can think of. If I do end up using it, I'll credit you. If anybody comes up with a better name or alternate ideas, feel free to suggest. All right, so all our tests can still pass. Exposed hidden information. I pushed out basically the association of the 987 with the 10% off. And I pushed it out through the fetcher. And why are you not paying full attention? Am I not the most important thing in your life right now? Come on. Man. Intro field. Intro param. Constructor param. Hey there, Tookie. All right, let's push that up. So this is one of the reasons why I sometimes like, sort of switching gears and writing new applications, even though this one is not anything useful to me. It's fairly realistic, and it gives me a chance to, one of the things as an educator, because that's what mainly I am, an educator either serving as a technical coach or doing training. The more different examples I have to show, here's how you do expose hidden information or collaborator. And so this technique of taking the literals or other constant information and basically getting it so that I can push it out through the constructor I do that just frequently enough that it's a good skill. And now once, it's one of those things that if you practice, you can then see opportunities to do it, and then you just do it. And it's much easier to do it than other ways, than perhaps other ways. And so it's one of those, you learn the skills and then you see places where you can apply it. And so my job as an educator is to find a bunch of different scenarios that I can say, hey, here's the scenario. We'd like to be able to do this, or we don't see this. Here's the steps you do it. This might be the next one that I write up. It's either this one. Yeah, it's this one because I now have 2 examples of pushing through the constructor. Hey, Tram Stars, have a good sleep, and thanks for stopping by. Pour yourself a drink. Okay, so all our tests pass. We've pushed out the information. Hello, Sanja? I'm sorry, that the D followed by an H is hard to pronounce. Hydrate, thank you. I was actually going to reach for hydrate. Oh, that was not what I expected. You ever do that? You ever you have a drink and it's like, oh, I thought it was going to be something else and it tastes weird? Because that's not what I was expecting. What am I creating? I am basically doing an exercise of supermarket checkout pricer. You can check out the repo. It has a README that describes what this is. And I'm attacking it from a test-driven development point of view, as well as hexagonal architecture. So this is the hexagonal architecture of this application. You scan products. It keeps track of them in a shopping cart. So they're products. You can get a receipt. And now I'm working on discount rules, which requires us to talk to an external service that doesn't yet exist, but it will exist. But we're basically writing the code in here to do that, all through test-driven development. So we just refactored our way, whoops, wrong way, to having this test implementation of the port for that service. Great. So we now have the ability to specify, at least for the stub fetcher, a single product represented by its UPC with a single discount rule, and that gets applied. Here, let's externalize, let's extract that. So one of the downsides of pushing things out through the stub is we ended up with all of our stub discount fetchers having this same rule. And I think we can replace most of them with just an empty one. So let's do that. So here we just need I kind of want actually a different fetcher, an empty one, empty discount fetcher, dummy. It's not really a dummy because it's going to look up the product and find none. Maybe I'll just create a constructor that doesn't take any parameters. So let's do that. So let's delete this, create the constructor. We're not going to change the signature. We're going to create another one. And this one we're just going to leave empty. So to me, fake implies something different. So I use Gerard Mazaros's terminology. So fake would imply that the test code, the code that I'm testing, is reading and writing to something when it has the word fake in front of it. In this case, it's not. It's not quite a dummy because it is actually used as part of the test code. So it's just an empty stub. It could be the no discount, the no discount fetcher. I don't know that I need to necessarily make a separate class for that. Sorry, what's private project? Is my GitHub repo private? Nope, it's public. I'm not sure what you mean by private project. All right, so we've done that here. So actually now we can just inline this. It does look like a dummy, but a dummy would be something that I'd actually like throw an exception here, and hi wheelall, to show that it's not used as part of the calculations or part of the execution of the code, but it actually is used. It is technically the node discount fetcher, and that's what I was saying before. I could create a separate class that maybe made that more clear. But the definition of a stub is to return a value. It doesn't always have to be related to its input methods. I could just, and that's what I had before. I'll always return discount 10%, regardless of the UPC. I was thinking static factory method for the stub. Yeah. Let's do that. But in order to do that, I'm going to basically change all of these to be just this. What do I want to replace? So that one. So I'm actually confused by this one. Oh, that's interesting, because this is on a different line. It didn't come up. All right, let's just replace all. And yes, of course, Wheatlol suggests I could create an abstract factory with 2 implementations. Hey, Enmahood. Why the find? That's weird. All right, let's make sure I didn't break anything, especially with search replace. There's always the possibility. So now I can basically take this, which is used in these places. Can I don't think it's on that menu. Extract, introduce. I thought there was an introduce static factory. Place and confer safe thought. I thought there was an automated refactoring to do that. Enterprise checkout price. Yes. Huh. I thought there was a way to do that. That's a bummer. All right. Then let's... Yeah, all right, Wheatlol. All right, so let's create a factory method. I swear there was a factory. All right, I'll have to look that up because I thought there was a way to migrate this to a factory. Can I extract delegate? What does that do? Yeah, that's not going to work. Okay. Okay, everybody ignore Wheatlol now. Yes, that's Tramstars. That's where we're dangerous. And why are you still up, Tramstars? All right, so let's create a method. We'll call it public static no discounts. No discounts No discounts? But then should it be on the I think just no discounts. Yeah, if I don't stop talking, and this has to return a discount fetcher. So return new stub discount fetcher. We can stop making this public. We can now make this private. And we've just broken a whole bunch of code. That's fine. Let's replace all of these with stub discount fetcher dot node. Oops. No discounts. I'll replace that with discounts. Oops. Oh, that's right anyway, because this is a method name. Now, that's hilarious. Okay. Let's push this down and leave that there. All right. That's not right because that's the wrong type. Whoops. And all our tests pass. Great. So now I can just pull this in. Great. All our tests pass. And done. Just in time. All right, let's commit. I don't know why I keep wanting to write feather instead of fetcher. Hey there, Hyper SE. Am I familiar with CSS? I am familiar with CSS. I am by no means an expert. I still consider myself an amateur. I get stuff done, but not always in the best way possible. All right. This is a wonderful stopping point. So on a future stream, we'll continue this. We'll go ahead and now that we have at least stubs for our discount fetcher and our product price fetcher, could I help you get alignments fixed? I don't think so. Plus, I'm ending the stream in a minute. But I'm not your man for that. I go to other people for that help. So now that we've got at least stubs of these things, we'll create two services. The product price fetcher, I might be able to use a third-party service. There's one that has an API. It's a little bit annoying because it basically returns prices for a bunch of different stores, which is kind of what we really want here. So I'm not sure, but we'll basically deploy well, I think I'll just write them from scratch. We'll write and deploy from scratch two services. I'll deploy them onto Railway. Because that way they're always up and doesn't cost much. And then we'll be able to probably should also work on this inbound adapter so we can actually control it from something besides tests. Maybe we'll do that first. So just something really trivial that has a single input field of the UPC. Receipt should work probably won't give us enough information, so there might be some more information we want to get from there. And then we'll create these two services. This shouldn't take much, because they'll be, even though they'll be technically separate services, we'll, in a sense, hard code what they'll return. Data depression. At what point do I pause TDD and run my app to check how my code is integrating? I will write integration tests. So so next time when I basically want to plug in this product scanner into the service, I will write a test at this layer. And so up here, this would be an integration test. And then I will run my application manually just to make sure things work. Right now, since I don't have any real adapters, there's actually nothing to integrate with, right? These guys are all stubs, then there's nothing real there. I don't even have one of these yet, and I don't have one of these, so there's nothing to integrate yet. But once I do have this, then I write integration tests. And then I will test it manually just to make sure. But the integration tests give me the confidence I need. And so I define integration tests in a very explicit way. I basically say that anything that crosses this line, I treat as an integration test. Yes, I will just write more tests and run them. And then the things that my test does not capture, which is basically what the UI looks like, because I don't write tests for that, then that's why I will run it manually. And then the manual is really a manual end-to-end test as well, because I don't find end-to-end tests being all that useful to automate. Well, it depends. But, manually running stuff, that's a test. It's just not an automated test.